Lesson 10-3, page 521. It says, graph the function g of x equals the cube root of x plus 3. Identify the domain and the range. I'll scoot it up a little bit. And I need me some real estate here. Now, before we do that, let's take a look at this equation here. What if we say that f of x equals a times the square root of x minus h plus k? All right, you're familiar with this. A is the vertical stretch or compression. And or, oh, our handwriting's terrible today. Let me fix that. And if it's negative a, reflect over the x-axis. H would be a horizontal translation. Left to right. And then K would be a vertical translation. Up or down. And we're going to want to remember the bx plus h and ay plus k. Okay, we're going to want to remember those. All right, so that's it. Now we're going to graph the function. Yeah. Let me right over the top of this now that y'all got that down. We're looking, A is 1, B is 1, H is 0, and K equals 3. Okay. Your point of inflection is always HK, which is 0, 3. 0, 3 is going to be right there. Okay. You also had another point, 1, 1. And we're going to use that bx plus h and ay plus k on that. And we got, well, b is 1 times x, well, that's 1. Plus h is 0, and then a is 1, and y is 1, plus k is 3. And that's going to give us 1 plus 0 is 1. And 1 plus 3 is 4. So we're going to have a point here at 1, 4. And the other one is negative 1, negative 1. And let's see, we're going to have 1 times negative 1 plus 0. And then 1 times negative 1 plus 3. And that's going to give us negative 1 and 2. So we got negative 1 and 2 is going to be right here. So our graph is going to look something like this right here. And there we go. Now what about the domain? The domain. If you'll notice, it's covering all the x values. It's got an arrow, so it's going to keep on going. It's got an arrow, so it's going to keep on going. So the domain is going to be x such that x is, well, all real numbers. So let's just do it like this. We'll write it like this. All real numbers. What about the range? Range is a little bit trickier, okay? Notice this is at an angle, so it'll eventually get way up here, and this is at an angle, so it'll eventually get way down there. Again, the range is going to be all real numbers. All right? Cool beans. Let's try number 2. Number 2. A is 1, B is 1, again H is 0, and K is -5. So our first point is going to be 0, -5. 0, -5 is going to be right there. We got the point 1, 1, and that's going to be 1 times 1 plus 0, and 1 times 1 minus 5. So I got 1 plus 0 is 1, and 1 minus 5 is -4. So 1, -4 is going to be right there. And we got -1, -1. 1 times -1 plus 0. 1 times -1 minus 5. And that's going to give us -1, -6. -1, -6 is going to be right there. And we're going to have something that looks about like this. And that's basically how we graph them. There's also the calculator. And let's do that. Let's graph this one here in the calculator. See how close we came. Cube root of x, step outside, -5. And then there it goes. Okay, Control T for the table. 1, -4, I believe that was one of them. 1, -4. 0, -5. 0, -5. And -1, -6. -1, -6, right there. So that was our 3 critical points. And let's go back. Describe how the graph of the function compares to the graph of f of x equals the cube root of x. Well, if I look at number 3, what I see is 6 is added to the cube root of 3. So I'm going to say k equals 6, and this is going to be a vertical translation up 6 units. And I'm looking in here, I got h equals 5. That's what's different. It's going to be a horizontal translation ION, right 5 units. And just for giggles, we'll graph that. See, tab. I'm going to graph just the square root, or the cube root of 3. And then to show you, we've got the cube root of x minus 5, and that should move it to the right 5. And we see that it did. 1, 2, 3, 4, 5. All right. What about number 5? We got two things going on here. One, we got a equals 1/3, and we have b equals -1. I didn't show you all that on the other one, did I? I did not. Oops. I did not. Let's put that up there. And so B would be a horizontal translation, stretch or compression and or reflect over the y-axis. We good? All right. So B is -1. So we're going to say a vertical compression by a factor of 1/3 and reflect over the y-axis. And here we've got B equals 1/5. So that's going to be a horizontal compression by a factor of 1/5. 7, we got a couple things going on in there. We've got A equals -2 and we have K equals 3. That's going to give us a vertical stretch by a factor of 2 and reflect over the x-axis. Plus, we're going to have a vertical translation up 3 units. And if we look over here at number 8, we got H equals -4, K equals -3. So let's see here. This graph will be horizontal translation left 4 units and vertical translation down 3 units. All right, folks, let's take a look at number 9. Step 1, A is 3, B is 1, H is -4, K is 0. Okay, so that's going to give us a vertical stretch by a factor of 3 and a horizontal translation left 4 units. Our first point is HK. That's -4, 0. HK. -4, 0 is going to be right there. And the first point, 1, 1. Let's see, what do we got? B times X plus H. A times Y plus K. That's 1 minus 4, that's going to give me -3. 3 plus 0 is going to give me +3. So -3, +3 is right there. And -1, -1. What do we got? -1 minus, that's going to give me -5. And -3 plus 0 is -3. So -5, -3 is going to be right there. And there we go. And we can check that. Tab. Let's go up front here and we'll put 3 times that was +4. And you'll see there it is. See how it has been stretched vertically and translated 4 units to the left. Let's try number 10. What do we got? We got A equals 2, B equals 1, H equals 0, and K equals 3. So we got 0, 3. It'll be right there. And then 1, 1. That's going to give us 1 times 1 plus 0. And 2 times 1 plus 3. That's going to be 1 and 5. One and 4, 5 ought to be about right there. And then let's see here, we've got -1, -1. And that's going to be 1 times -1 plus 0. 2 times -1 plus 3. And that's going to give us -1 and 1. Negative 1 and 1 is going to be about right there. So we're going to have, let's see, it'll be something like this. It looks something similar to that. All right. What else we got? Number 11. I would like for y'all to graph. So we're going to say graph on your own. We good? If you need to, stop the video and whatnot. Looky here. Now we are given a graph, and we are to write an equation that it works for. Okay. Well, let's see. What do we know? Well, the point of inflection, HK. All right, that is going to be right here, and that is -2, -2. Okay. So we have g of x equals a times the cube root of x minus -2, or x plus 2 minus 2. All right. Well, let's pick a point here. And just for giggles, we'll do this one right here. And this one is 6, 4. Okay. You can pick either one. I just 6, 4. So I'm going to put a 4 in here for g of x. And then I got a and cube root of, and then I'm going to take 6 out of here, the 6 there, plus 2. And then minus 2. So add 2 to both sides, and I get 6 equals a times the cube root of 6 plus 2 is 8. So 6 equals a times 2, cube root of 8 is 2. Divide both sides by 2, and I get 3 equals a. So my equation is g of x equals 3 times the cube root of x plus 2, got too much roof there, minus 2. Not too shabby. Let's try another one. (13) HK. That's the hard part. You got to find the point of inflection, and I'm going to say that is right there. Okay, and in this case, that's going to make it 2, -6. So g of x equals a times the cube root of x minus 2 minus 6. This time here, I'll just pick this point right here. And that's a 2, 4. That's going to be -6, -2. So I'm going to put a -2 in here. Equals a times the cube root of -6 minus 2, and then it's going to be minus 6. So I'm going to add 6 to both sides. I got 4 equals a times the cube root of -8. Well, the cube root of -8 is -2, So 4 equals a times -2. I'm going to divide both sides by -2. I get -2 equals a. So my equation is g of x equals -2 times the cube root of x minus 2 minus 6. We good? Now what about 14? 14 is a little bit different because it's got a b in there, but it's not all that different. It's the same thing. Okay? So I want you to find the equation on your own. Oh, good. We got us a word problem. The length of the side of a cube is modeled by s equals the cube root of v. Graph the function. Use the graph to find s when v is 48. Okay. Well, let's see here. So s equals the cube root of v. That means h is 0 and k is 0. Okay? A is 1 and b is 1. What we could do is, well, put a 0 in. The cube root of 0 is 0, so we got 0 here. All right. And probably the next one I'd use is 8. What is the cube root of 8? That's 2. And then, let's see, what would be another? 27. Okay, that's 24. 27. What's the distance there? We got, that's 4, 20, 16, 20, 24. That's 28 right here. All right, so 27. What's the cube root of 27 is 3. So I'm going to say that's maybe right there. And then the next cube would be 64, right? Cube root of 64 is 4. And so it's going to look something like this. Now let's see here. When v is 48 here, that's so we're looking at somewhere around in there, and that's what, a little over 3.5. And just for giggles here, we'll go 3, 48, 3.6, and there we go. So here's 3, 3.5. So it's the cube root of 48 is approximately 3.6. All right? Easy peasy. Folks, that was a great job, and I will see you tomorrow in class. Have a wonderful evening.